All right, greetings YouTube, beautiful mind here, and we have a series of 5 questions from calculus that we're gonna. It looks like they're pretty much involving the integral, right? So the integral is like the area under the curve. It's the reverse. I like to think of it as like reverse differentiation, and so we'll explore some techniques for taking the integral. So here we actually evaluate the integral. You can honestly look at these as two separate integrals. You have the first term. Again, terms are things that we add and subtract. Factors are things that we multiply and divide. So if we consider the first term, right, that integral is like the power function. So you can really just focus on the t squared. The 2 is just going to kind of linger in front. So the integral of t squared, when we take the derivative, the power comes down in front, and we subtract 1 from the power. So the integral, now we kind of do the reverse. We add 1 to the power and we divide by that new power, right? So the integral of t squared is going to be t cubed over 3. The integral of t to the 3 halves, let me see, that's going to be t to the power of 5 halves over 5 halves, right? Okay, so let's kind of work here. So this next line is going to be the integral as t goes from, actually no. So the integral of t squared is going to be t cubed over 3 plus t to the power of 5 halves. We would say divided by 5 halves is the same as times 2/5, right? So if we divide by 5 over 2, that's the same as multiplying by 2 over 5, right? That's dividing by a fraction. We want to evaluate this integral as t goes from 0 to t, okay? 0 to 9, okay? So let's see. 729. Okay, here, let me do this real quick. So, okay, when we plug in 0, it's going to collapse to 0, so we can kind of ignore that for right now. This first term, we're going to have 2 times 9 times 9 times 9 divided by 3 plus the square root of 9 is 3. So that's going to be 2 times 3 to the power of 5 divided by 5, okay? And then normally, you know, all of this would be in parentheses, and then we would say minus, and then whatever answer we get when we plug in 0. But again, in this instance, when we plug in 0, this second term collapses to 0, so then all we really need to simplify is this guy here, okay? So then this 3 turns this 9 into a 3 is 6 times what, 81? 6 times 8, 36, 42, 48, so 486. So this is going to be what, 486 plus, nothing cancels. 9 times 9 is 81 times 3, 243. 243. Let me see, 3 and 3 is 6, 1 and 4 is 8, 486. So then, ultimately, let me see, 6 and 6 is a 2, carry the 1, 6, 7, carry the 1, 8, 9, 72. Okay. So then, we have a way that we can actually check this guy. So, if I break out my trusty dusty rusty, let's just close these tabs. Oh, that's canceled. That's what I want. Okay. Reload and refresh. Okay, so I'm going to go to my y equals. The function is what? 2x squared plus x to the power of 3 halves. Okay. Go back to my home screen, hit math, go down to the very bottom, number 9. I have fn integer. I want to take the integer of the function we just inserted with respect to x as x goes from 0 to 9. And we should get 972. It's taking its time. Okay, let me check. Y equals 2x squared plus x to the power of 3 halves. Let me check again. X cubed over 3, 5 halves over 5 halves. Okay. Oh, wait, yeah. Is that a fraction? Oh, I think I made a mistake down there. I think I forgot to divide by 5. Okay, I see where I made a mistake. But again, that's the beauty. Like you check it, something goes wrong, you go back and review your work, and then you find out where you made your mistake. Let's get rid of this. Okay, right here is where I think I made my mistake. So 9 times 9 is 81. So 6 times 81. 480. I forgot to divide by 5 there. So plus 486 divided by 5. Okay. Let me kind of work over here. 5 into 48 is 9. 36 would be a 7. 2. 3, carry the 1, 10, 18, carry the 1. Okay, right, again, I think I forgot to divide by that 5, and now I think we've got the same answer that the calculator got. Okay. 583.2, 583.2, right? So again, we were able to check it, we found our error, we fixed the error, we can move on, okay? So that question, that was the first question in a series of 5, and we'll be back momentarily for the second installment. And now, from one beautiful mind to another, I'll see you in just a moment. Peace. And we're back. All right, greetings, YouTube. Beautiful Mind here with the second installment of a series of 5 questions from calculus. Here we're asked to evaluate the integral. We have the integral as x goes from 0 to 1, 4x to the power of e plus 9e to the power of x dx, okay? So again, we can work this as pretty much 2 separate integrals. This first term, and you can also just kind of, the 4, you can factor it and just go and put it in front. So this is really just the integral of x to the power of e. So I think the last time when we took the integral of a power, we just added 1 to the power and then divided by that new power. So this is going to be 4x to the power of e plus 1 divided by e plus 1. Okay, we're just going to leave it like that. And then we're going to say plus. And again, because we're taking a definite integral, meaning we have these endpoints, we don't need the constant of integration. We don't need that plus c. So because we have this guy, we don't need the plus c. Okay. The integral of e is itself I think divided by the coefficient a. There's a little bit. So basically, when you take the integral of e, you definitely want to check that term by itself by taking the derivative and make sure you get back to the original to make sure that you have the proper integral, right? So for instance, at first glance, it might be tempting to say, oh, the integral of 9e to the x is 9e to the x, right? But if we take this derivative, the derivative of 9e to the x is itself, hey, maybe we're good. Yeah, maybe we're okay. I was going to say, because sometimes you need to divide by something, but I think that's when the numerator is different. So, and I think we can also check this one as well, like we did the last one, in case this isn't working out. But again, so this one looks okay. So there is a little nuance or caveat when taking that integral, but I think this one is okay. Okay, and we want to evaluate this integral as x goes from 0 to 1. Okay. So let's plug in 1 first. When we plug in x is 1, 1 raised to any power, what is going to be 1? So then we have what? 4 over e plus 1. When x is 1 there, plus 9e, or 9 times e. So that's when we plug in 1. Now we got to say minus. When we plug in 0, looks like the first term collapses to 0. e to the power of 0 is a 1, so plus 9. All right, okay. I'm going to kind of work over here. Shrink this down just a little bit. Let's try that one more time. Okay. From there, honestly, I would just use my calculator. So like an exact answer, e plus 1 for 9e minus 9. And then for an approximation, I'm just going to put that in the calculator. We probably could get like a common denominator. But that's, let me see. E plus 1, E plus 1. Okay, let's just see. Let's just simplify this. Let's get an exact answer, and then we'll get an approximation. So, for instance, let me see. E plus 1 under 4, 9e. Now we're going to multiply this guy by 1 in the form of e plus 1 over e plus 1. And this guy, we're going to do the same thing. Okay, I'm just curious to see what happens here. So the top, we're going to have a 4, 9e squared, 9e minus 9e minus 9 all over e plus 1. Okay, so then this is a little bit extra. You don't need all this. What is that, a negative 5? Almost difference of squares. So 9e squared minus 5 over e plus 1. So that's an exact result, and then we'll use a calculator to get an approximation. So then if we said, what, 9e squared minus 5 over e plus 1. Okay. And then, you know, however many decimal places. If they want an exact, use the result on the left. And then, you know, just if they want you to round, you just got to round properly. 03. I'll do 0302. Okay, I got this result. Okay. So then to check this guy, I go to my y equals, and let me see, we have this 4x to the power of e plus 9e to the power of x. Okay. Let's see. As x goes from 0 to 1. So this won't give us the exact, this should give us the decimal approximation, provided we did it right. We got the same thing, right? So we can be confident in our result. Okay. So with that, that concludes the second installment of the series of 5. And from one beautiful mind to another, I'll see you in just a few minutes for the next installment. Take care. And we're back. All right. So greetings, YouTube. Beautiful mind here for the third installment of a series of 5 questions from calculus. Again, these questions tend to be centered around taking an integral. Here we ask, consider the following integral, where x goes from -4 to 4 of f of x dx, where f of x is this piecewise function that you see here. All right. Rewrite the given integral and then evaluate. Okay. So we have this piecewise function when as x goes from -4 to 0, the function is just a horizontal line y equals 4. But then on the right side, as x goes from the right side of 0 up to 4, we have this downward facing parabola, 16 minus x squared, okay? If we want the integral as x goes from -4 to 4, we can break it up into two integrals. The first integral will be as x goes from -4 to 0, right? So here I will put a 0. Okay, and that corresponding y would be 4. And then we want to take the integral as x goes from 0 to 4 of this 16, and here would be the 16 minus x squared. Okay? And then evaluate the integral, right? So with the piecewise function, typically we break it up in that way, based on those intervals, based on the x intervals, right? So let me rewrite this. So if we want the integral as x goes from -4 to 4, f of x dx, we're gonna break this up into the integrals x goes from -4 to 0 of 4 dx plus the integrals x goes from 0 to 4, 16 minus x squared dx. Okay? So now for that first integral, again, the constant, integral of a constant is just what? X, or in this case it'll be 4x. As x goes from -4 to 0, 4x as x goes from -4 to 0, right? Because when we take the derivative, we get back our 4. Then we'll say plus, integral of 16 is what? 16x minus x cubed over 3 as x goes from 0 to 4. Okay, so now we have several calculations that we need to do. When we plug in 0 in that first part, we're going to get a 0, and then it's going to be minus. When we plug in -4, we'll get a -16, so it'll be a double negative becomes positive. Okay, because you got to say the upper limit, the answer from the upper limit minus the answer from the lower limit. Did I do that right? That minus that, that minus that. Yeah, let's keep going. Okay. So now for the second part, we want to plug in, when we get 4, 40 plus 24 is what, 64? What's in 4? 16 times 4 is 40 plus 24, 64 over 3. Okay. So when we plug in 4, we get this result. Now we should, if we plug in 0, it collapses to 0, so we can kind of ignore that. Otherwise, it would be minus the answer that we get from 0. So then here we need to combine like terms. (64, 74, 80) 240 over 3 minus 64 over 3, 200, so minus another 24, 200, 180, 176 over 3, 5, and 8 times 3 will be a 24 and 2/3, so 0.6 bar. Okay. So again, with this guy, this is one that we should be able to check in the calculator. So I think that's what I'm going to do. Piecewise, how do we do that? There is a way to do it, I just gotta think about it. Okay, I'm gonna look that part up real quick. Let's go full screen here. Okay, what is this, TI 83 plus? How to grab, that's not a 2. How to grab piecewise function on TI 83 plus. I just need an example. Show more. Can I just see a completed example? The Y editor. Okay, here it is. So your first function in parentheses, the restriction in parentheses, plus the second function with the restriction in parentheses. Okay, I think we got it. Okay. So then right here, and I want this one. Okay. All right, so what we're going to do here to check, we're going to go to our y equals and clear. So now that first function we're going to do in parentheses was a 4 as, let me see, we got a -4. Now if I hit second test, less than is number 6. I guess we put our x. If I go back to test, 6 again, less than or equal to 0. Okay, and then I think we do a plus. The second function in parentheses, 16 minus x squared. And then 0, second test, number 5, x is less than or equal to 4. Okay. All right, I'm going to assume that that is proper. And then I'm going to try taking an integral like we did. We want to evaluate this integral as x goes from -4 to 4. Let's see if we get 58.6 repeating. Let me, 24. That was 24. Hang on. 5 is 15, 26. How come that's not 2/3? Maybe that's not a 6? Oh wait, we're getting... Okay, so we made a mistake somewhere. Let's back up. 16, 64, 74, 80 over 3, 240. Let me see, 200 minus 24, 200, 180. Oh, I think that's where it is. 180, 176. No, we got our 176. 5, 26, 8. Okay, let's back up some more. 0 minus -16, so that becomes positive. Okay, when we plug in a 4, 40 plus 24 is 64. 16 times 4, 64 over 3. Did I subtract those? Yeah. When we plug in 0, we get 0. Is this, where am I making my mistake? Let me back up some more. 4 dx, 16 minus x squared. Did I square x? Let me see, 16 or 6x, x squared, x cubed over 3. Let me see if maybe I typed it in the calculator wrong. Let me check there real quick. If I go to my y equals 16 minus x squared. I gotta try to figure out why are we getting different results. Four goes from -4 to 0. 16 minus x squared goes from 0 to 4. Let me check here. I feel like that's okay. All right, let me check my numbers. 4x, 0. 4 times 4 is 16. It would be a negative 16, but we got to factor in that negative. 16, oops, shyster. I think that was 4. Okay. Okay, let's see. That's a 0. That would double negative is a positive. When we plug in a 4, 16 times 4. 4 to the power of 3. That's fine. 0 is all gone. Okay, 16 plus 64. But yeah, I'm subtracting. 40, you got 24 left. 76. Minus 64 over 3. 58. 58.6. Okay, so maybe why I don't know why we're getting different results. 16, 64, 64 over 3. But if I go here, negative 4 to 0 plus 16 minus x squared. And if I go number 9, evaluate this function with respect to x as x goes from negative 4 to 4. Okay. I'm trying to figure out where I might be making a mistake. Yeah, it's irking me. I'll give myself like a few more minutes to see if I can find the error. It might be something that's positive. It's been moved up by 16. Okay. Yeah, I'm not seeing the error. I don't know if I'm doing something in the calculator wrong or if there's some concept that I'm missing. 4. Negative 4 to 0, and then 0 to 4. That's a 4x. Unless I'm doing that wrong there. But it doesn't make sense to do the negative 4 minus 0. It should be the 0 minus the negative 4. Let me see if I make that a negative 16. Does that change the result? And maybe I'm doing something wrong there. So instead of a positive 16, if I made that a negative 16, no, that's not it. Oh, so I'm kind of stuck here. I'm not getting them to sync up. I'm trying to think if there's some other way. Oh, I know. Okay, I'm gonna pull out. I got something I can do. Um, let's see. Cause now, let me just see. Mm-hmm, 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 mm-hmm. Are incorrect. The rewritten integrals on the test screen, they have both the wrong expression. The work at the bottom is actually correct. It shows the proper decomposition. 176. Hmm. Hmm. Am I forgetting my x squared? I got x squared. Hmm. Let me see. It says the rewritten integrals on the test screen are incorrect. They have box. Oh yeah. We got that. Yeah, we did that already. The work is actually correct. It shows the proper decomposition integration, just not the box part above. Yeah, that's fine. So I'm trying to figure out why is this not showing up properly in my calculator. Okay, let me see if I go like this. And then if I'm going to recall, so I'm breaking down, I'm going to go ahead and use ChatGPT. 85, 176 divided by 3, 176 divided by 3. Yeah, why am I getting different answers here? Okay, so I'm going to ask, why am I getting different answers? Why am I getting different results than the calculator? Calculator. Question mark. Okay. Small math mistake in your handwritten integral. Evaluate each part. First integral, 16. I got the positive 16. Second integral, 58.6 bar. Your handwritten mistake, you wrote 64, then you wrote 240. The math is actually fine, but you wrote, okay. Your second image shows 58. Okay, let me clear this out, and I'm gonna get to the bottom of this. Hang on. Okay, let's go like this. You're not wrong at all. You just wrote the decimal. No, that's not it. Okay, let me try this one more time. I'm gonna leave that. Can I zoom out some? Okay. Hopefully it'll let me do it. Why am I getting a different answer from the calculator? Why am I getting a different result than the calculator? Okay, let's see what it says this time. It's not the same, blah, blah, blah. Now, ChatGPT is saying that the 58.6 bar is correct. You're entering this, but based on your equation is incorrect. This uses inequalities with angle brackets, 0 or 1. Okay, maybe I might. So the evaluate is like a piece one. That part is correct in theory. Like, okay, as x goes from, okay, so this is saying that When I type this in the calculator, you should write 4 times, oh man, oh wow. Okay, so it's saying I'm typing in the calculator wrong. Okay, it's the compound inequality on the right that we're not getting proper. So let's clear this out. We're going to say, okay, so we're getting that we're typing in the calculator wrong. And it's suggesting that we type, now saying do a double parentheses. We're saying x second test is greater, so 4 is greater than or equal to -4. And then it just says times x is less than or equal to 0. Number 6. Okay, so that's the first one. And we got to close off our parentheses properly. Then we're going to say plus 16 minus x squared. And then we got x is strictly greater than 0, which is 3 times x is less than or equal to 4. Okay. So we had to break up that compound inequality. The way I wrote it, it wasn't registering in the calculator properly, so I had to break it up into like its individual parts, right? Okay, so now let's see if this works. Man, that was an adventure. It should get 58.6 bar. Wow. Okay, so that makes me feel better that at least we did it by hand, because I've checked it several times by hand, and you know, the numbers were panning out. Yeah, so we got to the bottom of it. We were typing it in the calculator incorrectly. It says that as one combined comparison by 83 doesn't support chained inequalities like that correctly. You need to break them apart using multiplication of booleans. So instead of the compound inequality, you had to break it up into the this and this or this. Okay. So we just had our inequalities typed in properly in the calculator. Again, that was an adventure. Again, we got to the bottom of it, so mission accomplished. That was a journey. So that concludes this third installment of a series of 5 questions. But again, you learn something new every day. That's why I was like, well, let's not get to the bottom of it. And you know, I let the recording run because you know you still need to be aware of like what it kind of takes for some of these questions, and you know, for the thought process. Anyway. So we got to the bottom of that and why I wasn't behaving properly. And with that, we're going to end the session here. And from one beautiful mind to another, I'll see you momentarily for the 4th installment. All right, take care and peace. All right, and greetings, YouTube. Beautiful Mind here, and we are back with the 4th installment of the series of 5 questions from calculus regarding integrals. Here we're asked to consider the following integral. We have the integral of x to the power of 5 divided by the quantity x to the power of 6 minus 2 dx. We're given this substitution, u equals x to the power of 6 minus 2. Find du, okay? It looks like we have a proper du there. So the derivative... so then the 6 comes down, 6x to the power of 5 will be the result there. Rewrite the integral in terms of u. Okay. So here, let me take some notes here. We got this x to the 6 minus 2 under x to the 5. We're taking the integral, dx. Our u was x to the 6 minus 2. Our du was 6x to the 5. Okay. We got the x to the 5. We got the x to the 6 minus 2. Okay. So if we want an x to the 5, we already got the x to the 6 minus 2. If we want that x to the 5, we need to divide both sides by 6. So then we'll have du over 6 equals x to the power of 5. Okay. So then when we go to make this substitution, it's going to be du over 6u. Right? It's going to become, because it's really du over 6, and then we would say what, divided by u, but it is, so when we say a fraction divided by another fraction, keep change flip, so we get du over 6u. Okay. So I'll put this result here. Okay, and then so now they want us to evaluate the integral. So we can, here, if we're going to start here, we got this du over 6u. Let's factor up that constant and move it to the front. So that's going to be 1 over 6 times the integral du over u. I think the integral of du over u is natural log of u. That's like a special case. Plus some constant of integration. And then now we back substitute. Our u is x to the 6 minus 2. So this should be 1 over 6. It's natural log of x to the 6 minus 2. Plus some constant of integration. Okay. All right, so that concludes this fourth installment of a series of 5. And from one beautiful mind to another, we'll be back momentarily for the final installment. Take care and peace. All right, and we're back. Greetings, YouTube. Beautiful mind here. Now, I want to backtrack to the previous question real quick. One augmentation, let me see. This, instead of parentheses, it might need to be absolute value. Right? I hadn't thought of the reasoning there. And I see you use absolute value. I think it looks like you just use absolute value improperly. Like you can pretty much get rid of both of those two guys over there. That's the only difference, right? So that the C doesn't necessarily need to be inside the absolute value. Okay. So with that question, that's the augmentation I would make there, along with like, oh shoot, they got the du there as well. So 1 over u. Okay, so that would be 1 over 6u, right? So here, what we have is correct, but trying to fit it into this thing, it looks like all you need there is a 6, and you can kind of ignore that one as well. Okay. Of course, he comes right. I'll just check it in a moment. Okay. So evaluate the integral. I think so at first glance, I'm tempted to try u substitution. So we're going to let u be 2x plus 7, right? So that means our du looks like it's just going to be 2 du, right? Sorry, not 2u, 2 dx, right? We got a 2x plus 7 on bottom. We have a dx on top, but it needs to be exact, so we need to divide both sides by 2. So we'll get du over 2 equals dx. So then now we can do our substitution. So then I'm going to write it like this. 1/2 times the integral of, it looks like it's just du over u. Okay. So then that integral is going to be what? 1/2 times the natural log. I'm going to do absolute value of u plus c. I should look that up to see when to use absolute value and when not to. I'm being lazy. Okay. And then the u, we back substitute 1/2 natural log of 2x plus 7 plus some constant of integration. Okay, this is the result I got there. can't really think of anything else. So with that, we'll end the session here. Let's see. Let me kind of glance real quick. I think it's your group. The way you're grouping it is what's throwing things off as well there. 2x plus 7 plus c. Yeah, it's a grouping, right? So get rid of these dual parentheses. Get rid of those, and I think you'll be okay. Keep the c, but get rid of those. And so it should look pretty much exactly like this, okay? All right, and so with that, we'll end the session here. And that concludes the presentation on the series of 5 questions from calculus, again, all regarding the integral. Something new I learned was how to put in a compound inequality in a graphing calculator, right? Once we fixed that, then we were able to get on a matchup, okay? So that was a true adventure, and with that, and from one beautiful mind to another, we'll end the session here, and I'll take care. Peace.